Hi students, welcome to Sunil's tutorial. I'm Sunil Mirwani and today we will be doing this chapter called as Kinetic Theory of Gases. Let's see this. Take down, we are doing numericals of kinetic theory of gases. The specific heat of air at constant pressure is 0.23 kilocalories per kg Kelvin, and at constant volume is 0.16 kilocalories per kg Kelvin. The density of air at NTP is 1.3 kg per meter cube. Determine J. Now I can say for principal specific heat, Cp minus Cv is nothing but R upon Mj. I can say also for 1 mole of gas, PV is equal to RT. Also density is mass upon volume. Therefore, I can say that volume is mass upon density. Multiply both sides by P. So PV is equal to PM upon density. But PV is equal to RT. Therefore, RT is PM upon density. Therefore, R upon M is P upon rho into T. Right? So substitute this value in the principal specific heat equation. So I can say Cp minus Cv is, instead of R upon M, I can say P upon rho T into 1 upon J. Since the experiment is done at NTP, therefore pressure will be 1.013 into 10 raised to 5 newtons per meter square. Temperature is 273 Kelvin. Rho is given to you. You can find out J. You will get J is P upon rho T Cp minus Cv. Right? You should get this answer as 4077 joules per kilocalorie. Next, take down next one please. If for a gas Cv is 0.753 kilocalorie per kg Kelvin, Cp is 1.250 kilocalorie per kg Kelvin, J is 4186 joules per kilocalorie. Find R for helium gas. For helium gas, I can say that molecular weight of helium gas is going to be 4. I can use principal specific heat equation. Cp minus Cv is R upon Mj. I have to find out the value of R, Cp, Cv, M and J are given to you. Solve the equation. You should get this answer as 8320 joules per kilomole Kelvin. Next, the principal specific heat of carbon dioxide, the principal specific heat of carbon dioxide at constant pressure and constant volume, at constant pressure and constant volume is 833 joules per kg Kelvin and 641 joules per kg Kelvin. Find universal gas constant if the molecular weight of carbon dioxide is 44. If the molecular weight of carbon dioxide is 44. Now in this sum, since J is not given to you, therefore I can say Cp minus Cv is R upon M. Right? So I can straight away find out the value of R. The answer for this sum should be 8448 joules per kilomole Kelvin. Next, take down next sum please. For a given gas, the difference between principal specific heat for a given gas, the difference between principal specific heat is 174 joules per kg Kelvin. Yeah. For a given gas, the difference between principal specific heat, is 174 joules per kg Kelvin. If the ratio of specific heat at constant pressure and constant volume is 1.3. Calculate the two specific heats. Now, I can say that Cp is equal to 1.3 Cv, right? But they have given me that Cp minus Cv is 174. So I can say that 1.3 Cv minus Cv is 174. After this, you can solve the equation and get the answer. The answer for this sum should be Cv is 580 joules per kg Kelvin and Cp is 754 joules per kg Kelvin. Next, take on next sum please. The specific heat of oxygen at constant volume is 0.155 kilocalories per kg Kelvin, and the ratio of specific heats is 1.4. Calculate R. if J is 4200 joules per kilocalorie. If J is 4200 joules per kilocalorie. Now they've said that specific heat of oxygen. We know that molecular weight of oxygen is 32, right? Now, let's see this. I can straight away use the formula Cp minus Cv is R upon Mj, where I can say Cp is 1.4 Cv. So 1.4 Cv minus Cv is R upon Mj. I presume we have all the values. We should be able to solve this and get the answer. The answer for this sum should be 8332 joules per kilomole Kelvin. Next, take our next sum please. The difference between two specific heats. The difference between two specific heats is 5000 joules per kg Kelvin. If the ratio of the specific heat, is 1.6, find the specific heats. If J is 4200 joules per kilocalorie. Simple, straightforward. I can say Cp is 1.6 Cv, but they give me that Cp minus Cv is 5000. So I'll get 1.6 Cv minus Cv is 5000. You'll get the value of Cv and then you can find out the value of Cp. The answer for this should be Cv is going to be 1.984 and kilocalorie per kg Kelvin, and Cp is equal to 3.175 kilocalorie per kg Kelvin. Right? Remember that J is given to you so that you can divide by J. Most of the students make this mistake. You will get, say suppose if you get the answer of Cp, you will get Cv as 8333. Right? You will get 8333 joules and you have got to convert that into kilocalorie. This is given to you in joules. To convert that into calories, you have to divide this by 4200. Remember that, okay? Otherwise, you will say that, sir, we got the answer as 8333.
You have to keep that control.
See, when you solve this, you will get, say, suppose if I get the value of Cv, you will get as 8333 joules per kg Kelvin. Now you want to convert this into kilocalorie. So this is nothing but 8333 divided by, they've given you the value of J as 4200 kilocalorie per kg Kelvin. So when you do this, you will get that answer as 1.984. Next, take down next sum please. The specific heat of argon, the specific heat of argon or argon, however you say it, at constant volume is 0.0752 kilocalorie per kg Kelvin. Calculate the specific heat at constant pressure Calculate the specific heat at constant pressure if R is 8310 joules per kg mole Kelvin and atomic weight of argon is 40 and J is 4200 joules per kilocalorie. Straightforward principal specific heat formula Cp minus Cv is R upon Mj. The only unknown here is Cp. You should be able to get the answer. The answer for this sum should be 0.125 kilocalories per kg Kelvin. Next sum please. The molar specific heat at constant volume is 6.77 kilocalorie per kilomole Kelvin and at constant pressure is 8.676 kilocalorie per kilomole Kelvin. Find J if R is 8410. If R is 8410 joules per kilomole Kelvin. Molar specific heat. For molar specific heat, you have the formula Cp minus Cv is R upon J. Cp, Cv, R is given to you. You should be able to get the value of J. Right? Answer for this should be 4226 joules per kilocalorie. Next, take down next sum please. The specific heat of nitrogen. At constant pressure and constant volume. The specific heat of nitrogen at constant pressure and constant volume are 0.246 and 0.175 kilocalorie per kg Kelvin. Calculate J if R is 8.31 into 10 raised to 3 joules per kilomole Kelvin and the molecular weight is 28 and the molecular weight is 28. Principal specific heat formula Cp minus Cv is R upon Mj. Right? You can straight away get the value of J. The answer for this should be J is 4180 joules per kilocalorie. Next, take on next one please. The specific heat of air. At constant volume is 0.155 kilocalorie per kg Kelvin and at constant pressure is 0.21 kilocalorie per kg Kelvin.
Constant pressure.
At constant pressure is 0.21 kilocalorie per kg Kelvin. Find gases constant if J is 4.2 into 10 raised to 3 joules per kilocalorie. Again same thing, principal specific heat formula Cp minus Cv is R upon mj. You should get the answer of gases constant. Here the molecular weight is not given to you, but the molecular weight of the gas is going to remain constant. So here your gases constant answer should be in terms of R upon m. Since m is not given to you, you will get that answer as 231 joules per kg Kelvin. Next, take on next one please. Calculate the difference. Calculate the difference between the molar specific heat. Calculate the difference between the molar specific heat if J is 4200 joules per kilocalorie and 1 kilomole of gas occupies 22,400 liters, 22,400 liters at NTP. NTP means normal temperature will be 273 Kelvin, normal pressure will be 1.013 into 10 raised to 5 newtons per meter square. They've asked me to find out the difference between molar specific heat. Now first of all I can say that by Gass's law, I can apply Gass's law first. If I apply Gass's law, I can say PV is equal to nRT. So from here, I can say R is equal to PV upon NT. Then I can apply molar specific heat formula. Molar specific heat Cp minus Cv is nothing but R upon J. But R we found out is PV upon NT. So Cp minus Cv is PV upon NT into J. You know P, V, N, T and J. You should be able to substitute and get the answer. The answer for this sum should be 1.979 kilojoules kilomole Kelvin. Next, find the latent heat of water. Find the latent heat of water having a volume of 1 centimeter cube. Having a volume of 1 centimeter cube. And occupies 1671 centimeter cube when converted into steam at boiling point at a pressure of 1 atmosphere at a pressure of 1 atmosphere converted into steam at its boiling point at a pressure of 1 atmosphere if the latent heat of vaporization is 540 kilocalories, if the latent heat of vaporization is 540 kilocalories per kg, J is 4186 joules per kilocalorie. Right, now let's see this. First, let's find out the external latent heat. External latent heat is nothing but PdV. dV is nothing but V2 minus V1. So I'll come to know my external latent heat. I can say that this will give me my external latent heat in joules per gram. Joules per kilograms, because I've converted it into SI units, right? Now, once I have this in terms of joules per kilogram, I can convert this into kilocalories. To convert this into kilocalories, this will be P V2 minus V1 upon J. When I divide it by mechanical equivalent of heat, this will give me in terms of kilocalorie per kg, right? Once you have this, then I can use my latent heat formula. Latent heat formula says that latent heat is internal latent heat plus external latent heat. Latent heat is given to you, external latent heat you've calculated from here. You should come to know your internal latent heat. The answer for this sum should be internal latent heat is 499.6 kilocalorie per kg. Next. Calculate the latent heat of water. Calculate the latent heat of water if calculate the latent heat of water if 1 gram of water having a volume 1 gram of water having a volume of 1 centimeter cube 1 gram of water having a volume of 1 centimeter cube wait, I think I've repeated the same sum. I've repeated the same sum. Guys, let's take down another sum. 1 kg of ice 1 kg of ice occupies 1 kg of ice occupies 1.1 into 10 raised to minus 3 meter cube at normal pressure. At normal pressure 1.013 into 10 raised to 5 newtons per meter square at normal pressure. When the ice is melted, 1 liter of water is formed. When the ice is melted, 1 liter of water is formed. Calculate the internal and external latent heat of ice. Calculate the internal and external latent heat of ice if J is 4200 joules per kilocalorie and latent heat of ice is 80 kilocalories per kg. Replica of the previous sum, right? V1, V2, P, L and J. You have to calculate internal and external latent heat exactly like the previous sum. I'm not solving, I'll directly just give you the answer. The internal latent heat should be 80.0024 kilocalorie per kg. Replica of the previous sum, right? Next, take down next sum please. Find the kinetic energy. Find the kinetic energy per centimeter square. Find the kinetic energy per centimeter square, per mole, per gram, per molecule at NTP if the molecular weight is 28, Avogadro's number is 6.023 into 10 raised to 23 molecules, and R is 8.314 into 10 raised to 7 ergs per mole Kelvin. Now, various things. Kinetic energy per mole. Kinetic energy per mole is 3 RT by 2. R is given to you, T is given to you, RT by 2. Should be able to get this answer. R is given to you, yes. R is given to you. So you should get this. Next. Kinetic energy, second part of the question is kinetic energy per molecule. Let's find out kinetic energy per mole. Since we found out, we can find out per molecule very easily. Kinetic energy per molecule is 3 RT upon 2N, where N stands for Avogadro's number. Right? Next thing they've asked me to find out is kinetic energy per gram. Kinetic energy per gram is nothing but 3 RT. Same. 3 RT upon 2N. Right? So it should be the here 2M, not N, per gram. 3 RT by 2M. Right? And last, they also asked you to find out kinetic energy per molecule. We found out per gram, per centimeter cube. Kinetic energy per centimeter cube is nothing but kinetic energy per molecule or per mole. Kinetic energy per mole divided by volume of 1 mole. So this is going to be nothing but kinetic energy per mole is 3 RT divided by 2V. Now the volume of 1 mole of gas is 22,400 centimeter cube. 1 mole of any gas occupies 22,400 centimeter cube. So you will have the volume of V as 22,400. You should be able to get the answer. Next, the answer for this sum should be, for the first part, answer for the first part is going to be 3407 joules per mole. For the second part, 5.65 into 10 raised to minus 21 joules per molecule. For the third part, 121.6 joules per gram, and for the fourth part, 0.3040 joules per centimeter cube. Right? Similar sum. Calculate the kinetic energy. Calculate the kinetic energy of 1 kilomole. Same sum. The only thing is this is in SI units. Calculate the kinetic energy of 1 kilomole, 1 kg, 1 molecule of 10 grams at 27 degrees Celsius. At 27 degrees Celsius, if the molecular weight is 32, Avogadro's number is 6.023 into 10 raised to 26 molecules. And R is 8320 joules per kg mole Kelvin. Right? So they've also said of 10 grams. Right? 10 grams can be written as 10 into 10 raised to minus 3 kilograms. Okay, replica of the previous sum, same formulas, except that there instead of
23 now. 6.023 into 10 raised to
26, they have given you here as 26 molecules. The data says 26 molecules. In the previous sum, the data they have given you the data in terms of 10 raised to 23. Ideally, it should be 10 raised to 23. In the sum, they have specifically given you 10 raised to 26. So you have to use the data that is given to you in the sum. Fine. The answer for this sum should be, for the first part, that is kinetic energy per kilomole is 3.744 into 10 raised to 6 joules per kilomole. Then kinetic energy per kg is 1.17 into 10 raised to 6 joules per kg. Next, kinetic energy per molecule is 6.029 into 10 raised to minus 21 joules per molecule. Right? And for 10 grams, the kinetic energy should be 1170 joules. Right? Okay, we'll stop this here for the day. Thank you very much.